In this video, I will go through 7 short principles how to write clean functions. The first rule is that you should use intention revealing names. So this applies to naming functions, but also to naming variables. In the first example here, we have 2 functions. This is the first one and second one, which both do exactly the same thing, but look very differently because the naming is very different. The naming is much better in this second case. More intention revealing names are used in the second function. So for example, compare calculate final price to just simple calc. This also applies to the input parameters and local variables in the function. Also, instead of just writing down magic numbers, we are using constants. So this is the convention of using constants in Python. We always do this uppercase snake case, usually at the beginning of .python file. This has several benefits. The biggest one is that we can actually search for the constants. So in this case, for example, imagine that we would like to search for the tax rate, but we can't really because the tax rate, which is this number, is just a number. So nothing will come up when we search for tax rate. But in this case, when we search for tax rate, we actually have this constant and then we can see what the value of that constant is. Another difference which you might notice is that we added one intermediary variable, this final price. In the first example, we just returned this x minus d plus t, but maybe the person that is reading the code after us doesn't know what that means. So basically by specifying and defining the name of this variable, we actually provide a piece of information that the person reading the code after us can use to make sense of the code. And this sort of information then forms part of the documentation. But we didn't have to write any comments or any doc strings, but the code explains it itself. Let's now go to the second point, and it is that the functions should do only one thing and do it well. And this has 2 benefits. So not only the function will be cleaner, but also when the function does only one thing, it is also much easier to come up with a good name for the function. So in this case, we have one bad example and one good example. So the name of the function in the bad example is process rectangle, which is quite high level and we are not really sure what process means. But the second one is more precise and it says that it's going to calculate rectangle area. And when we look at the function body, we see that in this example we also print something which is a side effect, whereas in this example we just return the rectangle area. This also violates the pure function principle, which will be mentioned in the point 5, because this print changes state which is external to the function. Let's go to the point number 3, and the point is that shorter functions are simply better. So in this example, we have split this function into multiple functions. The first function is actually not that long, but it's just for illustration. In reality, in the real world, each Python function should ideally be shorter than 25 lines. And if you see a Python function which is over, let's say, 35 lines, it is suspicious because Python is very succinct language and it allows you to write quite a lot of functionality in not that many lines of code. The basic argument why shorter functions are better is that the shorter the function is, the easier it is to understand what it is doing, and also splitting a longer function into several small functions gives us lower complexity code because we can see what each function takes in and what it gives on the output. Also in this example, when we split the longer function, we actually have to come up with these function names which were not anywhere in the previous function. And as described previously, when we do this, we actually provide a bit of useful information for the reader reading the code after us. Point number 4 tells us that fewer parameters the function has, the better. It is just much faster to understand a function if it takes only 1 parameter compared to 3 parameters. Also, it is much easier to do any unit testing when the number of parameters is small, because the number of combinations that the potential parameters can take will grow exponentially as we add more and more parameters to the function. So that's why in this example we have passed this user info dictionary. It also could have been accomplished with data classes or pydantic classes. The rule number 5 is that pure functions are better. So pure functions are functions which take in parameters, the arguments, and then just return the output without modifying any global state. So in this case, we have a global variable result, and the first function, instead of just returning, will modify this global function, and that's basically the way how this function returns the value. But that's bad, because using a global state generally is bad. And that's because when you start using the global state, it's basically identical to all of your functions, having not only the input parameters as you are defining in the code, but also all the global variables. So you can imagine that it's the same as if you had the function and then also you're passing all the global variables as more parameters, which is bad because you are passing stuff into the functions outside of the function signature. So this is not readable and will lead to problems. A good example in this case is a pure function, because it just takes in input and returns the output and doesn't modify any global state. So this is an example of a pure function. Previously, in the previous point, for example, number 3 or in number 2, I mentioned that this print statement is a sign of the function not being a pure function, but actually print is usually quite acceptable, because even though we are using a global state, so we are printing to console, so state somewhere has to change so that it can actually print what we are printing, right? In a production code, we wouldn't use print, but we'll be using a logger object, and that's the way how we would communicate with the global logging state. And the logger object will be usually a global variable which would be passed implicitly to the function. Implicitly just means that the object or the parameter is passed into the function without explicitly, so without writing down the parameter here. And basically all the global variables are passed into functions implicitly. So explicit parameter passing is fine, implicit is not. Let's now go back to the point number 6. The point number 6 is saying that Boolean arguments are generally bad. So this means that when we have a function and as parameter passed to the function, we have a Boolean value, so either true or false. This usually means that the function is doing two different things and is basically violating rule number 2, which says that the function should only do one thing and do it well. So in this case, we can split the single function with the Boolean flag into two separate functions with different names and more descriptive names too. Because the functions that only have a single level of abstraction are generally easier to read. So in this example, we have a bad example where we are doing a bit of statistics on this input data, but then also formatting output, which is going to be in the form of a string, and then using f strings, we just use the values which we just calculated previously. So in this case, the two levels of abstraction is first calculating the statistics from data, and second, just formatting the output. So two tasks which are very different and not that related. So it will be better if we just encapsulated both of these functions so that we hide the complexity, for example, from calculating the statistics into a separate function, as well as for formatting the report. So these rules are quite simple, but it will take time for you to start using them. So for example, next time when you are solving a next lead code problem or next assignment, maybe try to think about a couple of these principles and maybe try to refactor, which means to improve the code you just written in line with these principles. Also, on technical interviews, this is something that the interviewers will be also looking at. So they not only look at whether your code it runs with the right complexity, but also if it is written nicely, if it is a clean code. So, for example, implementing some of the rules which we just went through. But also, in my opinion, it is more important to first implement good solution with good enough complexity, and maybe then, if you have time, maybe ask the interview that, oh, I think that I can make the code a bit cleaner, for example, by doing this. So should I take time to do this, or should we just go to the next problem? So this is a question you can ask to the interviewer, and it shows your understanding of clean and maintainable code, and your understanding that making a code run is not the final goal of writing the code.